Hi, friends. Welcome again to another episode of Beyond the Clouds, Edge to Edge Transformation. And this transformation is taking us to different dimensions, not only on Earth, but even in space. And here with us today is Raj Pai. I knew him from campus. He worked in the commercial industry for many years, starting his journey at Intel. And now he's doing something really exciting. Raj, tell us about you. How did you end up becoming the Raj Pai we know, working with rocket scientists and everything?
Thank you, Shankar. Thank you for the opportunity. I've seen some of the videos and you do an incredible job getting some stellar aspirers on your channel here. I grew up with very modest means in India. When I reflect back and think about what brought me here, there are two things that my parents instilled in me. One was definitely being curious, and the second was being very thankful for what you have at any time in your journey in your life. The curiosity part, my dad used to be in banking, and nobody in our entire extended family had ever done engineering. I remember in middle school, I got to do one of these radio kits that you get to assemble, and that perked my interest, which led to me focusing on engineering, getting to IIT. Even in IIT, I was thankful I was surrounded by an amazing cadre of students who have become now lifelong friends, including you, where I got to see how technology can be used for different purposes. Then that journey led me to come here to get my graduate study. My first job out of college was at Intel. Since then, it's been an amazing ride out here in the Valley. I've been in the Valley for almost 30 years. The first one third was in computing. And like we were talking before, when we started, it was at Intel. It was all about speeds, getting amazing computing power into the hands of everyone. At Intel, I worked in the core research and development teams, starting with the 486 DX2, moved on to Pentium. After that journey, I decided, okay, I got to try something else. And that was the wave of connectivity, where a lot of the applications that existed, whether in clients or new web-based applications that were coming up, needed to be connected together. And I worked at two amazing companies. One was Tibco, which looked at connecting applications. And then the second one was Informatica, which is looking at it more from a data perspective, connecting the applications, but you're also collecting the data. Can you use it for decision making, for other kinds of analytics that were just evolving at that time? And the last part of my career, looking at application solutions, and I call it the intelligence era. AI, ML, machine learning. We have amazing computing, we have amazing connectivity, and now it's all about how can you harvest that to create applications in the cloud more and more or on mobile. These applications are not just telling you what's happening currently, but can predict and be prognostic in a number of different verticals. And throughout this journey, Shankar, I've been really fortunate to have worked in different vertical industries also, starting with Intel and computing, and then during my years at Informatica and Tibco, I worked in financial services, telecom, healthcare, and more recently, I've worked in smart grid energy. And right now, my current job is at NASA. As you can see, my backsplash, I get to work with rocket scientists, real rocket scientists who are amazing folks who are extremely talented. And here we are, get to work in the aeronautics industry. I don't have any background in aeronautics. I've learned over the last 5 years, and it's amazing. You'll see some of the pictures in the background here. We work on safety efficiency in the airspace operations, working with other agency partners. We work on experimental flight, which is pushing the envelope on how fast you can travel. So you can see one of our supersonic jets on my left here. During the early days, when the Concorde first came out, there was this issue with sound, and especially when this Concorde traveled over land. So we've now built an experimental aircraft that takes care of the sonic boom that gets transmitted to the ground. So we've reduced it to almost like opening a door, which is phenomenal. And we're doing tests, working with partners. We have a distributed electric propulsion aircraft that is on my top here, which is going to change the impact that aviation has on the climate. And we're looking at distributed electric propulsion vehicles. Last one is, if you remember the Jetson era, where you could sit in an autonomous flight and be carried around. It's good enough. We have these vehicles which are built on electric. We call them eVTOLs. They can use other kinds of fuels also, but eVTOLs are the most exciting part, where you can use electric vehicles to take off and lift and travel, and they can be autonomous also. So really exciting stuff. And one thing I like to see is The work at NASA, all of this is underpinned by all the digital innovations that have happened over the decades. We use computing, we use data, we use for every aspect of the life cycle, right? For design purposes, for testing, when we do experimental flights, for sharing the results with our stakeholders, with our other agency partners, or we work a lot with industries. I never thought growing up in India, I'd be working at NASA throughout the journey, right? From IIT to Intel to my public companies now at NASA. Every role that I have gotten into has always been referred to me through a close contact or someone I knew at a previous job who said, maybe this will be an interesting company, an interesting journey for you as your next step in your career.
Exciting. It reminds me of all the movies we used to watch when we were in college. Star Wars, and along with our kids, Toy Story. It's like you're
Yeah.
going to infinity and beyond. That's
Yes.
amazing. So, Raj, I remember at one point you worked on energy and the grid. Tell us a little bit about this startup.
One of the startups I worked on before I got to NASA was working in the smart grid energy space. We think of electricity and how electricity was invented. It's always a one-way thing. There's generation and it gets distributed to consumers or to factories and industrial users. One of the things we found at that startup, and this was the basic tenet with which the startup had started, that as more renewable resources like solar, wind, other forms of energy come in, the grid needs to be more distributed. These are not large generation plants, coal powered, wind powered, hydro powered, but we need to think of the grid itself as a distributed asset. Our startup was focused on distributed energy resource management, balancing the demand and supply in the grid. And more of these assets, whether it's a large power plant or your thermostat at home or a pool pump or industrial equipment, they were getting connected to the internet. How do you balance demand and supply? And one of the key innovations that we came up with is collecting large amounts of data and building this cloud connected applications. So on a peak consumption day, we could manage the supply by reducing the consumption by sending notifications to consumers or turning off pool pumps and getting industrial equipment not to be working at that point, which was an amazing startup. It ran for several years. We were fortunate that the company got acquired by Schneider Electric. We worked with many partners, many utilities out here in California. We work with PG&E, National Grid, NextEra. Even globally, we had customers that we were working with because it's a global phenomena. It's an interesting journey to see how connectivity and data and cloud-based applications can even influence the smart grids ecosystem.
That's amazing. Tell us about how your life has changed, starting with the hardware stack at Intel, and then the entire e commerce, and now really impacting people's lives in a big way. I know NASA applications eventually make it to commercial applications and day to day life too.
Initially, like I said, it was a focus on getting computing. And once computing became ubiquitous, it was more about the software. In my current role at NASA, a lot of it is putting systems together and how do you manage and deploy these systems, not just designing them and developing them, but getting them operational and operating at scale. Most of these systems now touch millions of users, have to be extremely safe, have to be extremely efficient. That's the evolution that I've seen. And especially now with more AI ML systems, of course, right now the focus is on applications that can be built. But if you think of the recent craze around generative AI and what large language models do, they're built on the foundation of having a lot of data available, a lot of computing being available, and then taking that power of data and computing, applying it to specific tasks like question answer or summarization or translation, or we use it a lot in simulation. More and more looking ahead, it'll be system level thinking. How can you take these building blocks of technology and apply it to problems in different vertical domains?
I recall reading somewhere that digital twins had their origin from the Apollo projects, where we had to simulate what it would be like for humans to travel to the moon. And now digital twins are everywhere. What kind of systems do you use now in simulation so that we can make flights safer as well as understand what is going on before we go there?
Great question. As you can imagine, at NASA, we have lots of simulation tools, a lot of platforms that we use. It starts off with what data you can get hold of. We collect incredible amount of operational data through flights that are happening today, commercial air that can move people as well as cargo. The challenge at NASA is we get all that data, but also we are looking into the future. And these flights have not occurred. So we need to simulate, create synthetic data. And then again, artificial intelligence, machine learning helps us create that data. And then we combine all of data, put them into systems. A lot of these cyber physical systems, where it's not just digital systems, you also have real life flying objects, right? How do you simulate every scenario, every corner case that can come up? Dealing with the uncertainty when these artifacts are deployed into real life, that becomes an interesting challenge. Looking at every combination, every possibility. And that's where the power of simulation, machine learning, and lots of access to big data makes a big difference.
Could some of these technologies be used in drones and other forms of transportation on Earth as well?
Yes, we do some really exciting work, Shankar, on unmanned aircraft systems. And in fact, some of my colleagues here at AIMS were the inventors of what we call UTM. UTM is unmanned traffic management. Very soon, it's going to be possible to have these unmanned aircrafts. And in fact, you'll see a lot of military applications already happening. But in civil life, use of these autonomous systems to move people as well as cargo. During COVID, we know some of the state and city governments were using it for emergency medical supply delivery. So yes, it can be used. Jokingly, I say internally, if you think of what a drone is, it is really a computer with a very advanced vision systems. No, it's more than that. They have a lot of intelligence, and how you interact with them, there's a lot of communication, navigation, surveillance that's required to deploy it in the airspace. But if you look at it fundamentally as a unit, it's an advanced computer with very advanced cameras that can have perception, can react to things that are happening, detect, and carry passengers and cargo between point A and point B. And one of the things we look at NASA is how do we make air travel more available to everyone? We have lots of airports here in the US. There's global growth in commercial air travel, but there are rural places where the connectivity through air travel is still very hard. And some of these drone technologies, whether it's for moving people or medical supplies or for even emergency responses, drone technologies are not just a nice to have or a technology gimmick. It's a necessity to connect those places and solve some challenges.
It feels like science fiction sometimes. The real life applications are amazing and can be life saving. Now, you have worked at so many levels of abstraction, starting from the chip and compute and software and data to now complete systems, robust systems, resilient systems. What part of your career would you say was the most interesting or challenging? And what did you learn from those kinds of things?
That's a great question. Part of that need for curiosity and learning has kept me moving from one thing to other in different industries. I think the first part of my career was more about research and development. I got to see how innovation is done at a product level, chipsets. Then in my mid-career, I was involved in all kinds of roles outside of core R&D, working with R&D. So I did product management, product marketing. I was a salesperson at one of my startups. And then I also did my own company from ground up, where it was incredibly hard. Every journey you learn more and more. And it's always fascinating to see a super successful CEO do things, but it's an incredibly hard role when you have to do everything together. Now, when I look at my role, I look at it more as an influencer role. I get to work with technology. How do you get people together to work on something which is in the future, which is innovative, but get everyone on the same page so we're moving ahead? If I reflect back, hardest part was doing my own company, right from starting registering your domain to getting people on board to getting first computer, setting up finance. It's a lot of hard work. That drill as the startup founder CEO doesn't stop. It's a 24 by 7 every day over years. That was probably my hardest job that I've ever done.
I've been through a few startups, and as exciting as it was, it can be also exhausting. The world celebrates successes, all the successful projects we've done, but often we also learn a lot more from our failures and the challenges we encountered. How was your attitude when things didn't go exactly the way you wanted it to go? and then you had to pivot.
Great question. The startup experience, it was a thrilling experience on multiple dimensions. We had a billion events that we were tracking. Think of it as Google Analytics for gaming and retail. It was in a hosted environment. Amazon Web Services, Google. We were probably one of the first few people that were doing cloud bursting using Google for storage and using Amazon for compute. We won fabulous awards. We were tracking 60 million users. On a product dimension, it was a phenomenal success. We had a terrific team of people. I still hang out with a lot of my co-founders and teammates. We raised capital, but commercially it was a hard journey because we didn't crack the code on what was the business model? How do we make money out of this venture? We went through several iterations. We did land up eventually selling the company to a larger company that was involved in the social engagement and gaming analytics space. Taught us a lot of lessons. Success is not just based on a great product or a great team. The lessons that I've learned is it also depends a lot on timing and you in the right space, in the right market. I'm learning every day. You think you know everything, and then there are always challenges. Like, for instance, at NASA, we are always looking 10 years down the horizon. You can imagine what the state of art and technology will be 10 years down the road. We have to connect the dots from where we are today, looking out into the future. And it's an exciting journey because we don't know. LLMs or ChatGPT didn't exist, what, 24 months back? And here it's radically transforming how we think and talk about AI now.
That's true. In fact, having been in AI in different stages of my career, it was still a big surprise to see that we are going at least one more big step towards generalized artificial intelligence that anybody and everybody can try using some of the richness of AI systems. What are the kind of things we can anticipate, say, a decade from now?
That's a great question. I'll answer it in the context of what I know currently with aviation. And we spoke a little bit about drones and how unmanned aircraft systems are coming. In aerospace itself, I see digital technologies playing a big role. When we think of digital technologies, it's not just for flying objects or flying things, it's also digital workflows for users. When I think of users, there's pilots who are flying, there are controllers who are directing traffic, there's operators like large fleets. You can think of commercial, FedEx, United, all these airline carriers, general aviation. Those roles are dramatically going to evolve on the strength of more automation, more autonomy, new flows, new digital workflows that we enable. It's going to look very different 5, 10 years from now. And there will be more traffic, more connectivity, more people will want to fly to different locations, different destinations, more delivery options, whether you want to get your favorite thing from your favorite online retailer, or you're looking for a medical supply, or you want to travel to different parts. It's very exciting when you look ahead and see what are the possibilities. We are working towards creating that future, and we work a lot with other agency partners and collaborating with other agency partners within the federal government, as well as looking at industry partners. It's never us doing all the pushing and innovation, right? There's innovation that's coming from industry also, and there's innovation coming from different parts of the federal government. So we work closely with them to see where the future will be.
How can somebody who is interested in any part of this industry, avionics, transportation, have a career at a place like NASA or in the commercial industry like SpaceX?
Just being very curious to learn. And I'll give you my own example. I'm not an aeronautics engineer, but the first thing I did when I heard there was an opportunity at NASA, of course, I have a background in machine learning, big data, and from my computing from my previous jobs. I took Aeronautics 101 book that is used at Stanford. I'm thankful I have a lot of friends who helped me along the way and who are experts in aeronautics. And they said, if you need to know aeronautic engineering about computational fluid dynamics, wing design, what's happened in the past, the history of aviation. How did we, right from Wright Brothers? I read through it. It took me a long time. I didn't get some of the concepts early on. I would go out to friends who are experts and question them, probe them. I learned it on the job. And if you are determined to learn a new space, whether it's avionics or aerospace or flying rockets or medical, there's so many things. If you're curious and you want to follow your dream and your passion, there's a lot of resources available today, books, internet. You can get an entire education online today. If anyone's interested in a domain, jump in and start doing and learning about it.
Robots will not make all these things fly and do it on their own.
I have two kids, and my son is graduating this year. He's doing his computer science and business degree. He was asking, so what's the future if there's going to be no coding jobs? There's going to be nothing. And I told him, you know what, fundamentally, it doesn't matter what kind of jobs will come in the future. You'll always need to be a thinker. You need to know how to solve problems, understand problems, and more people who can define problems and look at problems and say, here's a possible solution. Those people are always needed, no matter where AI will take us, no matter what kind of automation we get in the future.
We live in very exciting times. I still remember 1969. I think it was Apollo 11 that landed humans on the moon. The technology at that time, in comparison today, was so primitive. Probably an iPhone or a Samsung phone has more transistors and technology than what we had in those days. Since you studied the history of avionics, how was it even possible to land humans on the moon with technology of those years compared to what we have today?
Yeah, it's a great question. Hats off to the inventors and innovators back then. There was no computers. We have powerful computers that we carry around in our pockets today, but there was nothing. There were no transistors. There was vacuum tube technology back then. They had to build everything from scratch, from first principle. And it was an amazing time and amazing innovation. And not just do it here on Earth, but take it all the way to moon. That was clearly a world-class team that did that. A lot of innovations have happened since then. And you fast forward to where we are today, we look at launches as now different ways you can take even a small Raspberry Pi and deploy it on a mission that's going into space. It's possible to do that. We work with a lot of schools, universities out here that want to carry a payload into space. A science experiment, it's possible to do that today because technology is available and you can create your own science experiment, reach out to any of these launch, including NASA, and have it as a payload be deployed into space.
It is amazing where we've come, and Raj, it is amazing where you have come in your journey as well. I still remember when we were kids, pi was an irrational number, and that's your last name. Now I'm realizing it's beyond the rational. We just had Pi Day, March 14th. So it's amazing that it is possible to go beyond the conventional and do things that we can only imagine. So, to people listening out there, this is why I talk to people from all walks of life. It's almost naive to think that the future is a linear projection of what we have today. It's almost impossible to predict with high degree of accuracy when the next technology will come about. But striving for it is amazing. And we have people like Raj Pai who are willing to go that extra mile, take that risk, and enjoy the whole process, the journey, along with the successes and failures. So if you in your journey find things that are beyond the rational and are challenging, please come forward. I want to know your story. I want to know how it's likely to change the world and how we can together co create a world that's even more interesting and fascinating than the world that we live in today. Thanks again, Raj. Such an exciting journey. And I look forward to someday visiting your office and getting a touch and feel for the technologies that you guys are developing.
Thank you, Shankar. We have amazing facilities here at our Ames Research Center, so we'd love to have you as a guest. And thank you for hosting me on your show today.